Hey, good afternoon, everybody. Thank you for joining my session that is called Data as a Discovery for Complex Cloud Native Environments. So it might look like pretty difficult, but actually the idea is pretty simple, so I explain it to you later on. Before we proceed, let me introduce myself. So my name is Rost, or Rosty. Multiple of things there. Here, the most important are to highlight. So here, I'm presenting on behalf of Booking.com because this is my primary employer. In most cases, I'm just a AWS guy, so I have all the AWS certifications and the golden jacket. But every time I travel somewhere, I forget it at home. So this time it is at home as well. And more, so I'm going some fun facts about myself. I'm a big Lego fan. I have a huge Lego collection at home, former chess player, etc., etc. Okay, so let's move on. So before we proceed, a few things about Kubernetes at Booking.com. Probably you heard that we use Kubernetes a lot. We have a lot of services that run within Kubernetes ecosystem. And I'd like to first of all share with you some details about what is this technical context where we build in our services. So first of all, does it work? Yeah, great. So first of all, we use Kubernetes somewhere since 2017, and a lot of things happened since that time, but this is where all our journey started and evolved over the time. Then, right now, we have hundreds of services, probably even thousands. I can't give you the exact number because of NDA, but it's really a lot. And another thing is there is a lot of teams who use those services, who develop and support and extend those services. Another point is, so we don't use Kubernetes as is. We use it as a wrapper called BKS. That means Booking Kubernetes Service. So that's why later on I'll show you some diagrams, but you need to understand that the reality is more complex and like it doesn't look like exactly how it is written on the picture because we have so many things within. And the most important thing here is that how we try to distribute our work. This also reflects some previous sessions. So how we establish and how it works right now. So we have a separately platform team who managed all the clusters and all the other underlying resources, everything, while product teams or service teams, they just deploy their services there. So for them, from the customer perspective, because this is where they are customers from the platform point of view, so they just create some lightweight service definition using YAML files, and this is how everything is deployed using GitLab CI/CD. So those are the highlights to explain the technical context. Because we will talk about data, and data is a huge thing in our company. Some numbers about data. As you can imagine, by the way, how many of your customers are Booking.com? Okay, a lot, but how many of you are disappointed by the customer service? Yeah, this is what happens. So this is where, just because, again, there are some pros and cons, but in general, it's very, very complex ecosystem and so many things going on there. And as you can imagine, we have a lot of data. And apart from security, so sometimes, from one perspective, we can call ourselves as data-driven company, from the other perspective, like compliance-driven company, etc. So some numbers that I can share with you right now in terms of data. First of all, we have hundreds of SQL and non-SQL databases. The amount is just crazy, and it's difficult, because of separation, it's difficult to count how many of them we know, and usually just be dependent on what you are doing. This is where you figure out, okay, I need to connect to data from this database or from that database, and this is where so I need to move further in order to get this connection and get this data accordingly. And the thing is, so we have those databases historically deployed to different platforms. So we still have some old databases in bare metal, even though we are trying to migrate all of them to cloud. We have databases, most of the databases I think are in private cloud. And some databases are in public cloud, in our case AWS, because it's not a secret, Booking is an AWS customer, so that's why we are trying to eventually migrate a lot of our workloads to AWS. But as it was also mentioned in one of the previous sessions, so it depends. So for some, because of some requirements, because of some specifics, some databases run better either because of cost or because of dependencies in particular environment. But this is the thing, so we have a lot of them across all those platforms. Then we have petabytes of data, probably even more, I don't know, but it's really a lot, so it's just hard to count everything. And this is where also because some data is tied to a particular teams, and even though they sometimes can share the exact number, but it's really a lot. And that's why when we're talking about migration or something else, some work with data, we should keep in mind that sometimes it requires huge scale. Then we have, again, because we have a platform for that, so we have a custom platform for ETL and data pipelines. So bottom line is, so everything all the data we receive, the data we handle, the data we send somewhere, it all goes through our platform that takes care of scalability, etc. So this is where service product teams should be focused more just on business logic, etc. And yeah, this is some connection to the topic of my presentation. So because we need all the time, we need to understand what is our data source and what we're going to do there. So in all our data sources, the ICA databases, we track everything user as dependencies or assets dependent on some internal software. So this is for the talk. I consider everything as an asset because eventually we are building right now some inventory user service now. So this is where we treat all our databases rather than assets. But historically before we tracked it as dependencies before migrating to cloud. So that's why we still use both terms, but it's more about data asset. So this is just a question. How many of you have a dedicated team that manages databases in your company? Okay, I see quite a few people. Then how many of you delegate database provisioning and management to the teams themselves? So in Booking, we use both because we have a lot of teams, but this is where the whole problem is. So first of all, point to the centralization versus decentralization. So because as I spotted before, also that using memes is a good thing actually right nowadays in any conference. So this is the picture number one. So yeah, so we can consider what might be better for a particular company or for a team, and we can have a back and forth discussions about everything. But the reality is, as you probably heard this joke, that it always depends. So there is no in some cases centralization might be better. In some cases, decentralization might be better. So that's why you might use either both, or you might use a particular one. But this is where the whole thing happened. So in our case, okay, what should we do? And this is the thing. So first of all, historically, yeah. Unfortunately, I didn't have such a big screen at home. Otherwise, probably I would just do a more detailed picture. So again, it's a very simple explanation. So there is not all the details which represent everything, but this is how we historically started. So we had a dedicated, we had a centralized approach. And this is where we had a dedicated team who managed all the databases. So you can see it, roughly speaking, you can see it on the screen. So we have two separate teams who own their separate services, some either separate namespace, etc. That doesn't matter. And we have a separate database layer. So this is what I mentioned before. So the notion of dependencies. So that's why in this case, if a team needs an access to the database, they request a dependency to to any of databases. So I put just 2 on the screen, but as I mentioned before, in the reality, it's hundreds of databases. So they requested dependency, and this is how they got their credentials. So, okay, they can do operations with the data in those databases. At some point, so probably at much smaller scale, it worked well, but then, so you can imagine the problem is, so first of all, it violates the overall approach when when we have a microservice, so we usually have a database for the microservice, so we don't do this thing. So obviously over time, we realized that it doesn't work well, and also it's just a mess in terms of supporting all this database layer and managing all the dependencies and problems around concurrency, data change, etc. So I put some highlights to what I just mentioned. So yes, so each team owns its service and a database layer, and this is the result. So it was just like, yeah, I put it challenging because I cannot say those words here. But this is where, yeah, so we realized that okay, it works. And I have to say that it still works for some services, for some very old services. But this is where we realized, okay, it doesn't work. Our centralized approach at some point doesn't enable well our teams to move further, because usually the thing was, so for instance, you create a new service here, you need some data, it takes quite some time to get access and also to think about how to share this data with other teams, etc., and also to notify other teams about this, and so many things. So this is really didn't work well due to multiple reasons. So this is where we realized, okay, we need some kind of separation. Let's do the right thing, and let's allow teams to create a database by themselves, just to keep it faster and align to best practices, etc. So this is where we changed it to this model. So you see the difference is that each team has its own database now and can do whatever they want with their data within the database. We still have a data lake on this picture, because at some point, again, this data sharing problems. So we just created a data lake and change data capture mechanism for the databases that data from which should be shared with someone. So at some point, it's some intermediate approach. So we still have this database team who own this data lake. The still old mechanism. So if someone needs data from data lake, the team needs to request the access. But if a team does not require any other data, so they can be more autonomous and just work with data just within their service. Okay, so it worked really well from the operational perspective, because this is what improved the speed of development, etc. And everyone was happy, because before, again, developers were not happy to wait a couple of weeks before they finally have the database to that database layer granted. Okay, so yes, so this is the highlights which I mentioned. Yeah, on top of that, so this is where we also put some observability here to this picture. So again, nothing special here. So because we wanted to keep some control over what exactly our teams are deploying. So this is where we used the Open Policy Agent to enforce some database things, some nothing special, again, some login monitoring, etc. Okay, but the problem was I put those 2 as the bullet points. So what was the problem? The problem was that before the database team who owns all the databases, they knew that what exactly is going on, which database is deployed to which environment, how it is configured, how it is scaled, etc. And also they enforce some security controls. But now, so we enforce some security controls using Open Policy Agent. But the problem was, so in this schema, if a team creates a database and if they do something with the data, we really, in this picture, we don't know what exactly is going on there. What is data? What is data model? What is data source, etc. Why I'm saying it was a problem? Because we have so many customers across the globe. So that's why we have some requirements specific, for instance, data locality, etc. We have, depending on data, we might fall under SOX or PI or PCI compliance requirements. And this is where, you know, if you delegate, if you allow team to take care about everything, but the question is, in the end of the day, how you can ensure that they did everything right. And let's say if they use PII data, that they masked it, etc., and have some also restrictions regarding access, a lot of things there. So that's why we and security team here was not happy about that as well. And they were the stakeholders who raised this concern. So that's why we had to come up with something to, on the one side, to satisfy the security requirements about the knowledge about data that belongs to a particular team, but on the other side, do not go back and do not return to that schema when we have a separate centralized database layer, because the reality was we already knew that it doesn't work well. So that's why we had to create some kind of discovery mechanism to track the databases within the separate teams and track some data model, etc., just to, again, understand data as much as possible. What is going on? What is the database? What is the schema? What is the type of data, etc., etc. So this is where we, again, we didn't want to touch this schema a lot. So that's why we come up with something like that. Yeah, it's complex picture. So the key thing is on the left side. So we basically, it's the same picture as before, but what has been changed? So I put some numbers as an agenda, but what are the highlights? So we realized that we need to like a separate sidecar, doesn't matter like how to call this. So like a separate service that can find the discover the databases, connect to it in read-only mode, and do some queries just to know what is the database and what is the data, what are the tables, etc. So in order to do this, we extended from the previous picture. So we extended the Open Policy agent by enforcing also some labels for databases as well. And based on these labels, so we created this discovery mechanism to the left. So we just on the schedule, we run a service that gets credentials using Vault, because we used HashiCorp Vault to manage the database credentials here. So the service that gets credentials, calls first of all Kubernetes API by using labels, just to find all the databases for a particular namespace or set of namespaces. So after that, the service gets credentials for databases using Vault, connects, and just runs SQL or non-SQL native based on labels query, just to get the details about the database, the tables, the data schema, if it exists, etc. And in the end, we store this data to, so I call this as AssetDB. So right now it's under progress. So we're going to use ServiceNow as our asset inventory service or platform. And also the thing that I didn't put it to the right. So for instance, when talking about logins, so we put logs to systems like CloudWatch, Loki, depending on the service. It might be multiple destinations. And for Prometheus, in most cases, it was Grafana. So this is how we build this, this discovery mechanism. Is it okay? I don't know, but at least it works, and it didn't touch the schema that we created before, also for this discovery. So it is owned by security team. So that's why security is capable of what exactly should be checked depending on the most recent state of the standards that we should be compliant to. And one of the things is, so I mentioned those things. And the last point is, so this same mechanism basically can be extended to public cloud datasets. So it's an open question whether we need to just still connect the service to AWS databases, or we need just to create a some AWS specific for AWS databases. It's under discussion, but this is how this schema might be extended to public cloud databases as well. So this is the discovery mechanism. Yeah, and also the last item is also in the schema, we have a clear separation of ownership, because like service teams now own the compute and their data. If needed, they can just share this data with a data lake. Data lake and other things are managed by database team, and all the like things related to observability are managed by observability team, and security managed everything related to security and compliance of the databases. So thank you. It was the end of my talk, and I tried to keep it shorter. And now I'm open to questions.
Thank you so much. Any questions out there?
Thank you. Thank you, Rostyslav, for your talk. I have a question. So you mentioned that this assets DB, yeah, this one. This asset DB collects, I don't know, the schema of the table, database schemas, and etc. And but usually, like developers, doesn't think about naming, and they are bad in the naming. And what you will get if your asset DB will contain such things like just name, title, whatever. So what it give you just this name of the columns or tables, because your compliance specialist probably will anyway need to touch to developer and actually get to know what exactly these fields contains, right? Or maybe I missed something.
Okay, so in short, this so your question is, so first of all, what exactly is within the database, and how does it work if there is some inconvenience regarding the data or some other things, right?
Yeah, I mean, you have a list of the fields, a list of the columns that, for example, database A or database B has, right? But it barely help you to match the compliance if you don't know what exactly this field contains, right?
Mm-hmm. So the thing is, this discovery, it's not just this check of the database, etc., because this is the thing that's so dependent on the columns itself, if they exist, depending on the nature of the service, depending on other labels, and again because of knowledge of the domain. So this is where, so at some point, depending on what exactly the database or data is. So it might be that in one case, a security team might have a high confidence that everything is correct. And in other case, yes, they may have some concerns or some questions about, for instance, like exactly the naming. So for instance, a column named blah, blah, blah.
Yeah.
It doesn't well. So this is where there's some mix of automation and human review. So just based on that, but based on this discovery, everything like reports. So they just like see some reports from the discovery, and also they have some queries against the database itself. So this is where they figure out, okay, if they have some concerns, this is where they accordingly reach out to the particular team in order to clarify those things and apply some changes if needed, or just have some like renaming, etc. So something that have to be done by the security team. This is what they just ask. So the thing is why, like, it's like not fully automated, but the most important is, so this is where, because before having this, the only way was just to like find the team and talk to them, just to get what is going on. But at our scale, because we have hundreds of teams, it was just impossible to do by human. So that's why it's kind of something that we have in order to understand who is deploying what to their with their service.
So this is just a good starting point, right?
Yes. So again, there is some still because some like confidence level. So at some points, like security team might have no questions about other stuff, and it's still. So probably, to be fair, maybe we will still run in this hybrid mode because the thing is at our scale, just because we have so many different things that teams are doing. So that's why I don't think that we could just automate everything and trust everything, because this is sort of, if you know, if we miss just one corner case related to PCI or something, it might be very bad.
Yeah, clear. Thank you very much.
Thank you.
Any other question?
Okay, thank you. I was wondering if these results, so these asset discovery data, are also accessible from the teams themselves. What I mean is that the security team, of course, can see everything, but the single teams can see the information related to their own namespaces and databases.
No, this is where teams don't have access to the central database, because this is where like a kind of source of truth for the security, and it's just purely for security reasons. So that's why, because and if team owns the database, they should know what is going there, but they have no control over what sits within this part, because this is where just the security owns everything, and just like does their job without allowing someone to influence any of things that are happening there. Also because of some separation, you know, just because for everything security and developers might have different point of view. So that's why, again, like if a developer wanna talk about something, so first of all, like what is the concern, and this is where again it's because it's all about security. So this is where a security team might usually knows much better what is exactly required, because they're just capable of supporting all the compliance standards.
Okay, thanks.
Another question, the last one, and then we go to the break.
Hi, thanks a lot for the talk. I just have a question regarding the logic and the architecture. So you choose, let's say, a batch-based scheduler, and discovery job is scheduled. Why you didn't choose, let's say, a stream-based, let's say, Kubernetes providing events and saying, okay, a database was created, and here will the policy be applied? What was the logic behind?
So your question was not why not just sending an email if a database is created? Why to create this complex mechanism, right?
Could be an email, could be just, you know, I'm thinking about sending, let's say, a webhook, something like this, an exporter to a stream, Kafka or whatever other stream platform, right? And then acting upon it would be maybe a bit more dynamic.
So the idea that you're talking about, it might work as well. So for this one, we choose this particular option because of some our specific requirements. So this is where just like it worked better. And one of the things was that just because again this part, so this is where we can use Kubernetes API. So this is again for some corner cases we can just get more details about the environment where the database is running compared to this like sequence pipeline. Because for instance, if the pipeline runs, so if something is missing, that's like we can do anything. But this is where we can be just a bit more sophisticated and also asynchronous in order just to depend on some conditions, just check more if needed, and do not have a long-running pipeline.
Okay, thanks a lot. Makes sense.
Thank you. So thanks again for your presentation, and I wish you a nice break. Here we continue at 3:15 with Simon Krünger.